Hello, everybody, and welcome to our first part of the FIDI Global Alliance webinar on blockchain for global mobility. It is just past the hour to start. Anybody who will be joining us as of now will just have to sit in and join in the fun as we go. Thank you, everybody, for taking the time to sitting into the session with us. I am Magali. I work at the FIDI office in Brussels, and I am in charge of everything related to marketing and communication in this office. Together with me, we have Sloane Brakeville from Fr8 Network, sorry for that, who will be presenting this fascinating subject. So today's agenda, we will walk through the basic concept of blockchain. So to understand what lies behind this very complex term. Sloane will also present some background and history of blockchain and bring it back to our world by giving the example of containers. He will also give some examples specific to the relocation industry, and then we will close with a question and answer session. So just a quick presentation of Sloane. It would be an understatement to say that Sloane is passionate about all things crypto and blockchain related. He worked for IBM's blockchain labs for a few years, where he was heavily involved in analyzing and developing blockchain and logistics solutions. During this time at IBM, he worked with many big Fortune 500 clients, such as big names like HSBC and Bank of America. In 2017, he left IBM to join Fr8 Network as the CEO, where he is now building tools to improve the communication and the visibility of supply chain organizations, and specifically tailored for the transportation logistics world. So I think it is safe to say that Sloane is a fervent advocate of how blockchain could be our next big thing in our world and in the shipping and relocation business. But I will let him, as the big specialist, explain how it works. So Sloane, please, over to you. Just give me a while to make you the presenter and share your screen.
Thank you, Magali.
Yes. Hi, Sloane, over to you.
All right, can you see it, the screen?
We can all see the screen. Please go ahead.
Okay. All right, thank you for the introduction. Yeah, so the blockchain is a very interesting technology, one that's definitely held my fascination for the plethora of uses for it in the last couple of years. And what I want to do is impart some of that wisdom at a very high level to you guys today. So please feel free to ask questions as we go along by typing into the chat box, and I'll be sure to leave some time at the end to go over that. My goal is to have this presentation done in the next 20 minutes or so, to leave plenty of time for answering questions at the end. And just like Magali brought up, the intention of this discussion is to go over a couple of major topics. First of all, what is blockchain? And can we give an example that is relevant to you guys? We want to talk about container history and how that relates to the industry that we're in right now. There's a lot of similarities between how containers became standardized as a physical standard for moving goods and how the blockchain is going to be useful in discussions for how digital information is going to be standardized and how digital information will move across the internet. We'll wrap it up with an example and then open it up for discussion at the end. All right, so first of all, what is blockchain? Blockchain is what we call a foundational technology. It means it exists behind the scenes of your technology stack, which means for most of you, unless you're involved in the day-to-day operations of your IT systems, you might not even know what's happening behind the scenes. But what you will notice is a change in how communication happens. Now, an example I like to give is in the is around a group message. Now, let's say everybody or 4 people are on a WhatsApp message, And the group here represented probably involves your transferee, the moving company, maybe a insurer or somebody else, or a bank, and what's being discussed is the actual arrival at the client site. So the mover comes in and lets the group know that they're at the client's house. Now, this message is naturally going to get sent to all the other members of the group message as expected. The mover, however, it slipped his mind that he was in the group message and decided to send a text message about how the client unfortunately did not do a good job preparing their house for moving and sent this unfortunate message. Now that again is going to get sent out to everybody. The client, chief among them, is now offended and hasn't seen the message, maybe just yet, but the guy who sent it in error wants to delete it. Now, deleting it from WhatsApp doesn't necessarily delete it on everybody's phone, but what it does do is it sends a appended message saying that the previous message has been deleted by the owner. Now, that's how blockchain tends to work as well. Somebody with the power to delete messages should not be allowed to delete it for everybody, because although a mistake has been made, that's fine. You can correct the mistake by appending the correction to the database, as opposed to deleting or starting over. The biggest issue with this example is that this messaging app is owned and controlled by WhatsApp. And WhatsApp has complete authority over what people can see. And that's a big issue in a couple of situations, particularly in the transfer of value from one person to another, like money. But that's what blockchain came in to solve. So let's look at this real quick. First, we have at the very top a model that demonstrates how WhatsApp controls what you see in the application. It's a centralized model. And it's good because WhatsApp has a vested interest in making sure that you have a great user experience. They want to make sure that they get to monetize your data and have control over that. Another similar model where WhatsApp has control over your information and over your data is down in the distributed section here in the middle. A distributed infrastructure, while a little bit less risky of failure, is still controlled by a single entity. There's an admin that is in charge of each of these individual nodes, and that's like having multiple servers in multiple different countries to handle the load of WhatsApp for that particular country's residents and users. But down here at the bottom is what the blockchain is aiming to look like. It's supposed to be decentralized, where each one of those dots represents an individual or a entity that is in complete control of the application that they're using. Nobody's telling them how to run certain things. It's completely up to them how they control it. But how do you make sure something works effectively when everybody is completely independent and you don't have one person in control? Well, that's the beauty of blockchain. It has come up with very unique solutions on how to handle that exact problem. Now let's look at a similar example where there's 4 people in a quote-unquote group message. And the people in this example are your port authority, your relocation management company, your transferee, and your insurance agent. Now, the blockchain works by having each one of these nodes connected to at least 1 or 2 other nodes in the network. So you can see here, the insurance company is connected to the relocation management company and the transferee. Then the port authority is connected to the relocation management company and the transferee. But that's not a problem if, for example, the insurance company and the port authority needed to get a message sent to each other, because they would simply just route it through one of the other nodes. Now, let's say the container arrived at port message is generated by the port authority. Of course, that gets sent out immediately to the 2 connected nodes. And then the insurance company gets it very, very shortly thereafter. Hardly any delays, but still it requires the information to be received, processed, and then sent out by the 2 nodes that are connected to it. The container is delayed at the port, and the port authority on this blockchain network, again, relays that message out to the 2 entities that are connected to it directly. The insurance company gets it shortly thereafter. Now, in the similar example, let's say the port authority made a mistake. The container is not delayed, and they just want to delete their message in case somebody hasn't seen it yet. Well, the deletion in a blockchain network, yet again, informs the 2 relocation management companies, transferees, and then shortly thereafter the insurance company, the previous message has been deleted. So that allows for a certain degree of integrity by making sure append only is the default rule for how information gets updated. So that's basically how the blockchain works, right? It's a append-only database where the information stored in it is shared amongst a decentralized group of nodes, where each node runs its own independent version of the software. Now you can imagine in this particular network you see in front of you that everybody has a decentralized version of WhatsApp on their phone, which allows for their individual handheld device to independently operate the infrastructure, and making sure that no one entity is going to be able to control what they see. All right, so let's run through a quick history of blockchain. It all started in the 80s when a big movement called the cypherpunks were starting to gain some traction. They were building technology and they were very focused on something called privacy. Now, the intention here was to make sure that if there was communication sent over the internet, that governments and spies couldn't immediately get access to that information. David Chaum, pictured here, was one of the leaders of this movement, and he built a lot of fascinating technology that we still use today. And, excuse me, sneeze. Hopefully it passes. Oh, excuse me. David Chaum invented a very interesting set of technology that he called eCash. And what it allowed people to do was to send money privately across the banking systems to each other. And being a big believer in private communications and making sure the government can't see into everything, eCash was the first real example of how that was going to be used beyond simply email, for example, and into the world of finance. Unfortunately, eCash failed. David Chaum was notoriously very hard to work with, and we didn't see a whole lot of innovation in terms of the digital money movement until the mid-90s when eGold was invented. Now, eGold, and in a similar model to eCash, was meant to send digital certificates of gold from one party to another. And because it's gold, it's like cash, it's anonymous, you can send it without a lot of information, but it eventually got shut down because it being anonymous was believed to be used for money laundering. And so the federal authorities in the United States came and made them unplug their servers and shut down the company, which is a fundamental weakness, yet again, of that centralized architecture we saw before. Now, after eGold shut down, the cypherpunk movement, again, David Chaum, big among them, started to create some new technology to help solve for these fundamental issues that made eCash and eGold fail. Hashcash was one of those things. It was a way of generating, a way of restricting access to complex resources like email servers by charging the computer that wants to use those email servers a fee. Now that fee isn't in cash or money, it's in computation cycles. And so by making your computer do complex math problems, it slowed down how much of those server resources it was allowed to use at any given point in time. That is the first we heard of what is now called proof of work, which is very, very widely used in the blockchain infrastructures of today. B-Money came along shortly after Hashcash. And B-Money was a sort of two-page essay, you could call it, that very shortly describes what would eventually become Bitcoin. And it involved interesting topics like how to generate new coins, or they called it B-Money, et cetera, et cetera, et cetera. But from all those, the building blocks eventually came Bitcoin in 2008. It launched in January of 2009, and if anybody has heard of Bitcoin, then you're part of the new revolution of how value gets exchanged over the internet. It's a fascinating thing. It solved a lot of the problems. It couldn't be shut down because it wasn't centrally controlled, and it is what I believe to be a very groundbreaking piece of technology that we will start to see a lot more of in the future. But it had some issues, and it has continued to be iterated on. Litecoin came around, and because Bitcoin was kind of slow, it took about 10 minutes to confirm the receipt of money. Litecoin sped that up to seconds, and Ethereum solved the problem of making sure that the the complicated transactions, ones that maybe involved delays in time, such as escrow, or even setting up trusts, could be done by allowing you to program how and when money gets transferred. So Ethereum was a big revolution and is a fundamental building block, topically, of all of these different projects that we see today. It's a very small subset of the projects that are happening, but it's a burgeoning industry. Tons of great ideas are being thrown around, and a lot of fascinating things are happening today. All right, so let's talk a bit about containerization and how it relates to where we are today in the moving industry. In the early days of shipping, things were loaded by hand by dock workers and longshoremen. It was a unionized industry, and they worked hard to make sure that everyone had living wages. But in typical fashion of capitalism, there was improvements that were made time and time again to effectively require less labor, because the most expensive part of shipping was not in fuel at the time, it was in the labor, the dock workers who moved your stuff from a warehouse onto the dock and then into the hull of a ship. And so to help with the costs of labor, some people began experimenting with containers, where instead of loading each individual bag of sand or bag of coffee or barrel of whiskey by hand, you could put a bunch of stuff at your warehouse directly into this box and then simply load that box onto a train or a vessel to move it across the ocean. However, in the US and abroad, this was outlawed, and it was mostly around the fact that these longshoremen had strong unions, and the standards bodies that set prices for how goods were moved across, particularly the U.S., refused to acknowledge that containers would allow them to tax things appropriately. But it didn't stop in Europe from forming a standards body and making sure that all these different containers that were being built could be effectively used by all the different companies in the space. It wasn't really until the early 1950s where a guy named Malcolm McLean in the US decided to take containers to the next level. He was running a shipping company that was focused on trucks. And what he did was he realized that instead of the trucks driving up the crowded interstate of the United States East Coast, he could put his truck bodies onto a ship and use that ship to bypass all the traffic going up the East Coast and then dock somewhere in the Northeast and unload all that onto the trucks up there. Now, what he found was that this saved about 97% of the shipping costs and allowed him to scale beyond belief. Picking up on that, Matson, another big shipping line company, decided to start using containers as well. Now, with two major shipping companies making waves in the logistics community using containers, everybody started to take notice. They wanted to participate in these wild savings. And so standards bodies got formed. All the buzz and all the interest about how much these people were saving their customers required somebody to start setting standards. So in the late 1950s, the first standards bodies started to be formed. And it really wasn't until the early 70s that those standards got adopted. So it took many, many years for people to debate, to argue, to talk about dimensions and weight restrictions before we ended up with the 10, 20, and 40-foot container standards that we see today. Now, in the past, right, the container represented a physical standard for how goods get moved, how physical goods move across the ocean, across trains, across in the air, and the movement of those goods required infrastructure investments. And that represents like a physical protocol, which are kind of rules for how things are going to move across the from one node, right, an airport to an airport to a port. And those standards were well adopted by the early 70s. Now, today, we're looking at something very similar, except for digital information, right? What is going to become the digital standard for how goods and information about physical goods move across the internet, and what infrastructure is going to be built up around that? that's where a lot of these conferences that are up and coming are going to help there. And that's what blockchain is spurring a discussion about. And as a quick reminder, a protocol is a collection of rules, behaviors, and formats that specify a communication standard between two or more nodes in a network. All right, so just a real quick run through who the leaders are, some of the big standards bodies out there working on just global logistics, not specifically for moving or mobility, are these guys. And at some point in the future, I'm sure they'll be releasing some very strong standards from which you guys can certainly learn and benefit from. And who are some of the protocol leaders right now? We have EDI, which anybody who's used EDI recognize that it's point-to-point, expensive, and not very flexible. And so there's a couple of great standards that are pushing things forward, like RosettaNet, UNCFACT, and GS1's LIM. Now, let's dive into some examples. I'm going to push this a little bit faster. We got about 5 minutes left before we open up for questions. What's going on in mobility right now? And it's not just mobility, it's logistics as a whole. There's poor coordination and integration. With so many small companies out there that are taking care of everybody's services, the integration is not necessarily the strong point. And what that leads to is low visibility. We have data that is re-entered frequently between the major players, and it leads to no global standards being set, with everybody using their own version of things like bills of lading or proofs of delivery. There's a struggle, right, with those integration costs to the future of how we're going to get it done, which is why it's so important to have these standards so everybody can build that infrastructure up around those standards and reduce those integration costs. So let's run through an example real quick. A transferee wants to know when his or her shipping container is going to arrive at their house. Now, a common question, I've got to take off work for a day to help make sure that the movers can drop this off. I've got to be there to sign off on the delivery receipt, et cetera, et cetera, et cetera. The relocation management company calls and emails 4 different individuals for its current location and expectation data. Right, so this is a common theme. The transferee is talking to a relocation management company. They have to then call the trucking company, the port authority, any number of individuals to figure out exactly where that container is if they haven't been notified on this current location in a while. 3 of those individuals, for example, have no information. They're like, hey, we already did our job, or we haven't received anything to tell us when to start. The one in control sends a short and incomplete email without all the information that the relocation management company needs to answer. And so what this leads to is a 2-day delay in response to the transferee's question. So how does that look like in the future with something like blockchain, where standards are set up and a protocol is in place for sending that information? Well, there'd be a global standard for what an update message looks like. So if a container was handed over from one person to the next, an update will be sent. If the container status changes, an update will be sent, etc. That message is going to be stored in this foundational technology like a blockchain that is a decentralized database, and then access to that data is going to be controlled to those individuals who need to know about that particular shipment in the database. So back to our diagram before, let's say we've got our delivery driver over here on the left who's responsible for picking up that container and taking it to the transferee, which is over here on the bottom right. We've got the warehouse owner who's currently holding that container for release, and the relocation management company who's sort of in control of all of this. The driver sends a text that's meant for the relocation management company saying, I went to pick up the load but got denied. That gets sent out in a typical blockchain fashion to all 4 individuals. Transferee now knows there's a problem. The delivery driver has been told that he needs another bill of lading. That bill of lading request gets sent out to the warehouse owner and the relocation management company, who then responds with, I'll get a copy sent within 24 hours. Again, transferee is nicely aware of all of this, although not responsible for this particular activity. They know that this delay is solvable, and that now with the relocation management company informing that delivery is now rescheduled for the following day, the transferee can immediately call in and inform their boss that they're going to now have to miss work for yet another day. And that's it. That's a user experience that we can expect with high communication with everybody integrated, all because standards have been set for update messages, and that data is accessible from a publicly available but privately controlled database. All right, so let's move into discussion. I'll pause here. Magali, if you'd like, you can take over and we can start answering some questions.
Thank you very much, Sloane. This was fascinating, and it's really interesting to see how the concept of blockchain, as far as I can understand it, looks like it would really be applicable and quite quickly and more or less easily to our world of relocation and international moving. We haven't had many questions. I hope this is because everybody was listening so intently that you forgot to ask your question. So please go ahead and type in your questions in the question box on the right-hand side of your screen. And in the meantime, Sloane, what I propose is that I read the question and you give your answer. Does that sound like a plan? Sloane?
Go for it. Yeah, ready when you are.
Okay, so the first question is, and it's actually quite a complex one and a long one, but it's exactly what we're looking for. The question is, does it make sense to use blockchain to track personal goods during a move? Or are there better solutions out there or alternate technologies available which would be better suited for the task? Sloane?
Great question. So the way I would design it would be major information that needs to be shared amongst the parties in a decentralized and secure way would get stored on the blockchain. And so those minor updates, like the current location in the ocean, for example, I don't think is necessary data to store on a blockchain. And it's because blockchain data storage is inherently expensive. By replicating everything across multiple nodes and forcing those people to store the entire industry or a lot of data in multiple databases that the blockchain represents is expensive. And so, yes, your personal goods need to be tracked, but I'd say a better solution would be to push that, minute by minute or hour by hour updates about its current location to a layer above the blockchain in a cheap database storage solution that is controlled by a maybe politically neutral or maybe FIDI or some kind of foundation dedicated to nonprofit, storage and retrieval of that data, and allow somebody to look at the minute by minute or hour by hour updates that way. It's much cheaper, it's much more efficient, and a much better user experience, I would imagine.
Thanks, Sloane. Next question. How do you maintain decentralization of authority and control and yet still maintain the infrastructure? Now, that's a good one.
Great question. Blockchain and Bitcoin, for example, is a great, let me use the word example again. It's a great example of how you can set up a decentralized infrastructure and still maintain everybody's independence. Now, that's hard to do without what we call in the game theory world incentives. Blockchain, or Bitcoin, has a great incentive model where by competing to solve that complex math problem I mentioned earlier, if you win, you receive the reward of newly, freshly minted Bitcoin. Now, Bitcoin is worth a lot today. And so by competing for that, you're going to be competing with a lot of other people. And so by forcing this sort of game theory model where everyone wants to run nodes and wants to input data into their database and the reward being new Bitcoin, you've solved the problem of maintaining decentralized authority because each person has a internal justification for running those nodes and maintaining that network, and that internal justification is new coins. Now, that's a fit for purpose blockchain, and say mobility, the motivation would be for your business to have better customer service. And by having better customer service, maybe lower margins, because you don't have to do quite as much phone calls and dedicate time and resources to finding information, you would be inclined to run a node as well. And the cost of running that node would be offset by the money that you save on the margin or the customer experience that you save in the new business that you get because of that in your business.
Next question. And this is more of a technical one. How could it be avoided that unfiltered messages would reach the clients directly?
So the client wouldn't be responsible for running a node. Typically, a transferee would be tacked onto a node that is owned or controlled by the moving company or the relocation management company they're working with. And so the relocation management company would then have, as it works today, a portal for the customer to access. And only the relevant information that the customer would need to know would go through there. It's highly unlikely that the transferee would, one, care about a container delayed message at port. They just want to know how it affects them. And so it would be the application designer it would be up to them to decide exactly what messages get sent to the clients.
Okay, now we have a couple of questions that go in the same direction, so I'll put them together, and it's more almost of a more philosophical, political question as with this one. What would be a timing we are looking at, meaning when or how long do you think before blockchain will be widely used, and how expensive would this be for the companies involved?
So blockchain's already in use. There's a lot of projects out there in logistics and in mobility that are using blockchain in one way or another. A common use is for documents, important documents that you want to have traceability on, right? If a history of changes to that document are very important to keep in a secure location, you can use some of the public blockchain infrastructure like Ethereum to store updates to that document. And you can know by going back in time and looking at that blockchain database and infrastructure if major changes have been made, and check and see if any malicious behavior has happened. So it's already happening. But at a full scale and one that entirely uses blockchain for the purposes that I've described here, we could be as short as a year away, depending how quickly the industry can mobilize, and up to maybe 5 years. Now, to me, if I go back in my presentation to sort of the history of containers and compare that to where we are today, then I would say we're sitting at probably the 1950s whenever the first full-scale experiments are happening. And we're still looking at a significant chunk of time until we adopt a lot of those standards. And it's going to be expensive at first, but as technology does, it gets much cheaper over time. And good design, good architecture is going to be the primary driver of reduction in those costs. And as the example I gave earlier, if you set up the blockchain to only store important information, which are major updates and maybe some things like transfers of ownership, then you're going to significantly reduce that cost.
Thanks, Sloane. So next question is, in the example you gave around the relocating employee, how and who decides who can access this information?
So the information is going to be controlled more than likely by a centralized party. Right now, there's a lot of experiments being done around decentralized identity management and allowing access to information in a decentralized way, but it's not very good yet. And so as the demands that the industry puts on technology forces compromise, there's going to likely be, at least initially, a central party that will control what we call access control rules. And it's a proven technology. I'm sure any of you who work for a major company are unknowingly being targeted by access control rules. For example, every time you log into your system to update something about a move, you might not have access to a certain part of that application because the administrator didn't give you the authority to access it. Now that's access control rules, and we'll have something like that, maybe FIDI, will be in charge of setting up and spinning off that infrastructure, and everybody in the industry pays a very small stipend to make sure it all works. And that small stipend will make sense because the benefits you get from this this infrastructure and these data standards are well worth that small investment.
Okay, now a question that is very close to our FIDI heart. If everyone has access to the database, how do you protect personal confidential information? And we can imagine GDPR not being very far away from this one.
No, it's a great question. So encryption is ubiquitous in today's industry. It's very cheap to encrypt, and what you'll see is only a couple of trusted individuals. And again, I like to focus on FIDI or one of these neutral or politically neutral standards bodies in charge of these sorts of activities, being ones that control access to certain pieces of that database. But the modern technology stack does have great solutions for these access control rules. And so it's going to be just a matter of design that controls access to private information. The blockchain itself will likely store encrypted information, and the keys to unlock that private information are then in control by this neutral body and can be destroyed whenever it's necessary to do so for GDPR reasons.
Thanks for that. Before moving to the very philosophical questions, just another one. Which current software players in our industry would you see as the leaders or innovators with blockchain technology?
So I have a small chip on my shoulder when I say IBM is actually really pushing and leading the way. I was part of the team that had the very first client project whenever I was at IBM. And as a founding member of the Blockchain Labs, I got to see where the company was focusing with their partners on bringing blockchain technology into the new design of the future. And TradeLens, being chief among them, is a great project that now is getting some significant momentum based on the hard work that IBM and Maersk did to build out that infrastructure early on. Fr8 Network, my organization, is certainly pushing the envelope in the discussion, but we're not quite as well adopted as I would say IBM and Maersk are. So take a look at them as I'd say the leaders and the innovators on this side, and then watch as some of the smaller guys like Fr8 Network and ShipChain and Vita push for major projects to focus on industry-specific applications for this technology.
And now on to the exciting, more philosophical questions that we're all thinking about. The first one would be, the international moving industry is a tiny fraction of the global logistics industry. How much progress has already been made by the major shipping lines and global logistics groups at the moment?
That's a great question. So progress has been slow, but it's been measured, right? To make a change this significant, it takes time, it takes investment, and it takes education. And so the major updates we've seen, and I'll go back to examples like IBM's TradeLens in partnership with Maersk and a number of other major shipping lines that have joined on board, are starting to put significant amount of data. But the big guys handling a lot of the movement are important to have on board. But what you really will see as the major indicator of success is when the smaller companies can afford to participate. I don't know about globally, but particularly in the US, 90% of the trucking companies are small businesses. They're owned by, they have maybe 6 trucks or less. And with 90% of the industry being small players, they can't afford, and they don't have the same technology budgets as the Maersks and the IBMs and everybody who's big and have that major investment. So as soon as the industry and as soon as the technology can become available for cheap for the masses, then that's where we'll start to see some major adoption and progress. But to answer your question, there has been some pretty significant progress, but it's been more on the education and the ecosystem side. And we see in the architectural design very little use of core blockchain technology. If you look at the IBM Maersk solution called TradeLens, you'll see that they really only use the blockchain for storage and retrieval of really necessary documents, not necessarily for a ton of message sharing back and forth.
Again, this actually leads us nicely to the next question, which actually it's three questions that go all together. So I'll ask them all at once. From all the historical presentation that you did, it shows that now we are at a point where someone has to develop the software and set up the rules of the blockchain. Isn't that a type of centralization? Who makes sure the software runs smoothly and gets updated when we need it? And does a central party controlling access not make way for monopoly? For example, TradeLens, one of the major critiques against TradeLens is that it's maybe too centralized.
Great complicated question. And the reality is, yes, TradeLens is pretty centralized. But if we look back at history, we've seen that the very first experiments are going to be done by a single individual or one company that has the financial resources to really test this out. Now, it's harder to test out network-based solutions, and containerization being a network type solution, we saw that the organizations that had their own ecosystem inherent to their company were able to experiment early on. That's why you see IBM and Maersk and some of the Maersk partners being the groundbreakers, if you will, of experimenting with blockchain technology. And so when we look at who's going to be pushing this forward, yes, it will take some of these experiments to help us learn about how this technology can be adopted in a way that is inexpensive and effective. And we'll see a push towards decentralization moving forward. Now, about the development and maintenance of this, the answer is yes, more than likely there will have to be a centralized or group of individuals who are motivated enough to keep this infrastructure up. But the reality is only part of the solution has to be decentralized and controlled by these, like no single individual. And we'll see in the future, and I'm happy to talk about this if anybody wants to follow up with me, a likely politically neutral body that is in charge of some of the standard settings and making sure that the technology and the infrastructure is maintained.
Great, thank you. Thank you, Sloane. I would say we are getting to the end of our session slowly, so maybe let's give it one or two more questions. I would like to remind everybody who is still listening that this is only the first part of our webinar, and that the second part next week will actually be the very the questions that we are asking now, which is what are the next steps for our industry and the global mobility world in general. So if you would like to continue this conversation, maybe keep your really political and philosophical questions for next week. So looking at the questions, actually, I do believe that they might be for next week. For example, there's one, maybe Sloane, we can close with this one and keep it very short. How do the standards then get set? Who would be responsible for setting the standards, or would this be a joint effort of all global moving organizations? Seeing we have very much industry-specific standards, it seems a cumbersome job to standardize this if we are currently not capable as an industry to standardize simple documents as pre-advices or waybills. Now, I think this is a perfect question to close this first part of our webinar. So Sloane, if you could just give it a very short answer, and I will give my very short answer from a FIDI Global Alliance point of view, and then we can call it a day.
Sure, yeah. It's not necessarily my job to set the standards. I'm a technologist, and so my job is to build the protocols, the infrastructure around those standards. Those people who are on a day-to-day basis using the pre-advices or the waybills, it's up to them to come to terms on what the basics of those documents consist of, and then putting those into a standard. It's not quite as complicated as you think, and it can become a very politically charged debate, but it's more about what the industry needs. It's more about solving short-term problems so that you can reach long-term success, and I'm sure it will be solved very soon.
And just to add on that, from a FIDI point of view, this is a very valid question that we ask ourselves all the time whenever the blockchain subject comes up again, because we do believe that from an industry point of view, the task of setting standards should come from an organization like FIDI, like the IAM, like all the other international organizations that are out there who have the legitimacy and the respectability to actually develop standards and have and create an engagement within the industry. So it is a question that we are asking ourselves throughout the relocation world, and we do invite you all to keep an eye out on the space, because I do believe that there will be some very interesting things happening within the near future. So I think we can call it a day for today, because this was a fascinating show, I want to say. I hope that you all enjoyed it very much. Thank you, Sloane, for taking the time and for breaking this very complex concept down to very understandable and very clear examples. I just want to remind you again that the second part will take place next week, that's the 25th of September at the same time, and it will be a continuation of this conversation. So just to quickly walk through the agenda of next week, it will be just a quick refresher of what we talked about today. Sloane will present a global mobility case study to just show again how the reality of blockchain could be applied to our world. And we will close off with maybe a longer Q&A session, because this is where we will really delve deep into the complicated and more philosophical questions. If you have any questions or comments about today's session, please send us an email to us at FIDI or to Sloane directly. You can also find us on social media, especially LinkedIn and Twitter. Please keep the conversation going. I think one fundamental thing to really get the awareness within our industry is to talk about it as much as we can, especially to take away the fear that a lot of our friends and colleagues have when they are faced with a concept that they don't understand. We will also be at the IAM annual convention in Chicago from October 3rd to 6th. Sloane will also be there for a very short moment. So if you have any questions or you would like to continue this conversation, do come over to our booth number 1220. I will be there, and my FIDI colleagues will be there with us. So it will be great to continue this conversation with you there. You will receive a follow-up email after today. The video recording of the session will be on our public YouTube page within the next few days, and as soon as I have it up and running, I will send you all an email to let you know. So that's it for today. Thank you for listening. Thank you for your attention. Thank you for keeping this very fascinating conversation going. I will close the session now. I wish you all a great day or a nice evening or a good night, depending on where you might be in the world. And I look forward to seeing you